without using the calculator, find the value of each of these. Okay, so you just got to remember now that this sort of value here is a power. Okay, so if you're on a calculator, you've got to sort of write it as an equation, try and solve that equation. Yeah, so to write this equation, put it equal to the power. Okay, put it equal to the power. We don't know what the power is. We don't know what the logarithm is. So let's say put it equal to x then. Okay, because I don't know what it is. Can't put it in the calculator. So let's just give it value x. Okay, well, now can we work out what it is? Well, we can, because we treat this, as I said, like an equation. Okay, and we know how to use this, how to manipulate now a logarithm. Okay, because remember, our logarithm just tells us what the power is, but we can rewrite this, can't we? We can rewrite it, but in a form that doesn't involve a logarithm. So remember now, the base is 3, so I could swing that base over and get rid of the logarithm. If I take the base back over, the logarithm disappears, and I'm just left with 81 on this side, and then we've got the base on this side to the power x. Okay, and then you can work out what that power x actually is. And if you know your numbers here, you can see what the power is going to be, because 3 times 3 is 9, but 3 times 3 times 3 is 27, and then 3 times 3 times 3 times 3 is 81. So actually x has got to equal to 4. Yeah, so in this case here, we can say that logarithm, okay, we can check on your calculator if we want. So the base 3 of 81 is actually equal to 4. Okay, the power is 4. So the same here. Okay, we want to work out what this is without a calculator, so let's put it equal to power x. Okay, and well, the base is 4, isn't it? So let's get rid of the logarithm. Okay, take the base back over to that power, so be 4 to the power x then, won't it? Base to the power, and then 0.25 on this side. Of course, we know 0.25 is a quarter. Okay, so if we write it like that, we've got now 4's that are connected, but of course 1 over 4, you can rewrite that as 4 to the power minus 1, can't you? And then you can see that x has got to be equal to minus 1. Okay, so in this case, that logarithm is actually equal to minus 1. Okay, same situation here. Okay, put it equal to x. X is the power. Okay, well, let's rearrange the equation. Let's swing that base back over. So I've got 64 equal to 2 to the power x. Okay, and the question is then, well, what is x? Well, 64 is a power of 2. And if you know your stuff, is 2 to the power 6. You can work it out. Okay, 2 times 2 times 2, keep going, and you get 64. And then, of course, then x has got to equal to 6 in that case, because the powers have to equal. Same thing here, equal to x again, that logarithm. We'll swing the base, 8 to the power 5 equals a, then the base to the power x. And when you match these up, you can see them, well, these are equal, so that means the powers then have got to match each other, so x has just got to be 5. So that logarithm there has just got to be 5, okay? Okay, so next one now we've actually got equations set up here, and they're asking us to work out what x is actually equal to. In each case, we've got x there. We've got x there as the base, and we've got x involved here. So in this case here, let's get rid of the logarithm. Okay, so let's take the base back over. Okay, so we get x equals then, so x will be left then when the logarithm disappears. The base is swung over. And remember, the logarithm is equal to this power 3. So the base 3 gets swung over to the power 3. Okay, and of course then that comes out to be 27. Okay, with the next one then, okay, logarithm base x of 81 equals 2. We're going to swing the base. Okay, so we get 81 equals x then to the power 2. Okay, so you swing that base over. Okay, x to the power 2, and then we're going to square root. Okay, now when you square root, in this case we don't need to put plus or minus, right, because the base cannot be negative. Okay, that's something we're going to learn about logarithms. The base has to be positive, so you don't bother write plus or minus. So that means x then will equal 9. And then in the last case here, then swing the base. So if you swing the base 2 here on the right hand side and left hand with the base to the power 4, and I got x plus 1 here. Well, I know 2 to the power 4 is 16, so x plus 1 is 16, and of course then I'm just going to take that 1 over, and I get x then is 15.